Hello, it's Ryan. In our last lecture, we introduced the idea of real and apparent motions when we look at objects in our sky and the way that they appear to move through our sky, or the real motions associated with those, the things that cause those apparent motions. So we discussed and defined and gave you a handout on real and apparent motions. One of the motions that I really want to discuss today is known as prograde and retrograde motion. So that's the basic and fundamental idea of this video today, where we're going to start with prograde motion. This is the motion we see usually when we look at objects in our sky. And when I talk about motion, I don't mean like you look up at the sky and you see a star move before your eyes. I never mean instant motion. I mean motion over time. So the most common example of real and apparent motion that you're used to is the rising and setting of the sun and the moon and the stars every day. They rise in the east and set in the west. That's the apparent motion. We see the objects in our sky appear to rise in the east and set in the west in most locations on the earth. The real motion is, of course, the idea or the fact that the earth rotates on its axis once every 24 hours, and that's what causes the sky to appear to move from east to west throughout the day. So that's an example of a real and apparent motion. Prograde motion is another type of apparent motion. It's when we can say that objects appear to move from west to east through our sky. And what we really want to say is relative to the background stars, objects appear to move from west to east through our sky over the course of days and months. So this is a type of motion that we observe over several weeks instead of just the normal east to west motion that happens daily. The motion that happens daily is called diurnal motion, whereas this is prograde motion. And I'll show you visually what I'm talking about soon. In general, prograde motion is what we normally see planets and the moon and everything do over time with respect to the constellations. The moon might not be the easiest example to think about because the moon is orbiting us. Anyway, retrograde motion is just the opposite direction of motion. So it would be when objects appear to move from east to west. So I'm going to give you a definition for retrograde motion, but just not quite yet. I just wanted to start you out thinking about prograde motion, and now I'm going to show you what I'm talking about. So this is a blurb. And what I've done here is I've pre-drawn a known constellation. So we've got, a lot of people call this Betel or Betelgeuse, this star. I call it Betelgeuse. It doesn't matter how you pronounce it. It is a well-known star. It stands for the armpit of the giant. This one's Bellatrix. This one down here is Safe. And this big one on the bottom is Rigel. And then these three are named Alnitak, Alnilam, and Mintaka. And those are the three stars known as Orion's belt. So this is Alnitak, Alnilam, and Mintaka. And of course, then you've guessed it, this is the constellation Orion, the hunter. It's been known through many different civilizations as some sort of hunter or something like that. You probably are more used to it being pictured like this. And then usually there's some stars out here kind of making up its shield. And then he's also usually, he's got a couple stars here that are harder to see. A lot of people have made that like a club or something. And then of course there's the Orion Nebula M42 that kind of hangs off of his belt. And it's cool to look at in a telescope, but that's M42, the Orion Nebula. So this is Orion, and what I drew around the edge of Orion is the constellation border. And that constellation border, believe it or not, is technically the Orion constellation. So students coming into the class and people in general usually think of a constellation as the stars you can see that look like something that people have been given a story for thousands of years, like Orion. It turns out the International Astronomical Union defines all of our astronomical definitions for us, and they define a constellation actually as the border that encapsulates all the stars that would be in the constellation then. So I don't really care for that definition, it's not my favorite, but that is actually the true definition of a constellation. I don't mind if in our class we think of the constellation as the stars inside. Some language, so the constellation is a well-known grouping of stars, and we actually define it by the border of those stars. There are actually 88 constellations according to the International Astronomical Union. So those are like the universally known now constellations. There are 88 in our sky. We can't see them all from our hemisphere, and that's okay. So in general, when we would talk about pieces of a constellation like Orion's belt, those are a well-known group of stars that come from one or more. We give those a different name. Those are called asterisms. An asterism is a grouping of stars that comes from one or more constellations, but is not a constellation themselves. So Orion's belt is an example of an asterism. The Big Dipper and the Little Dipper are examples of asterisms. So this is several stars that come from one or more constellations. That create a different known pattern. So there's some definitions for you. Orion's belt is an example of an asterism. The Big Dipper and the Little Dipper, and others. Of course, there are many others. The Summer Triangle is one. There are many others. Okay, so I drew this though so we could talk about these types of motion. So what I'm going to do is just get rid of some of this stuff. So we can talk more about the motions. So there is Orion in all of its glory. Okay, so in general, what astronomers have noticed for thousands of years, really, or at least 1,000 years, remember in class we left off in 350 BCE with good old Aristotle. And so we've been watching these what we call planets now since before the Common Era. And so what we can do is I'm going to model something for you. In general, if we're looking up at the sky in the winter, we might see this beautiful constellation we call Orion. And if we're lucky enough, maybe Mars will be out. And Mars is definitely visually red when you look at it. So maybe Mars will be out. And this might be, oh, I don't know, January 13th or something. So I'm just going to put some date, some random date that we might see Mars. So we have Mars at some random date. I could also note that if we are looking at Orion like this, then we would be looking in the southern sky. And so this would be the western sky, and this would be the eastern sky. And so the normal motion, the normal apparent motion that we would observe would be Mars over the course of weeks and even months, slowly but surely traveling from west to east through the background stars. So by the time Mars gets here, it might be January 30th or something like that. And Mars might get here, it might be February 12th or something like that. Maybe we'll say February 25th. Maybe Mars will get to here. And so over observing this over the course of a couple months, maybe March 5th, over the course of a couple months, we will literally see Mars, or apparently see Mars, go through Orion and continue on its way. What we noticed over hundreds of years of observing is that sometimes Mars would be doing its regular prograde motion, and then all of a sudden February 25th might arrive, and 26th and 27th will happen, and Mars will appear to stop moving. It won't continue on its prograde path. Over the course of the next couple weeks, we would actually be able to see Mars start to back up with respect to Orion, move from east to west for a few days, stop again, and then continue on its prograde motion. And so I'm going to draw that little path. So normally we would see, so I'll do the normal path in pink. Normally we would see Mars progress like so, but every now and then we would see Mars stop, back up, and then continue on its regular course. Excuse me. This is retrograde motion. It's the it's the backing up of Mars with respect to the background stars, and in our case, the background stars are Orion. So I'm going to define that for you. So we had a definition for prograde motion. I'll define retrograde motion. Retrograde motion is the backing up of a planet with respect to the background stars. So we could say, in other words, we know that this would be east to west motion with respect to the background stars. And so again, I can show you, we would watch Mars make this back up and then continue on its normal path. And again, that would take several months, or at least several weeks for us to see that. Every day, the diurnal motion, the rotation of the Earth, will allow all of these things to rise in the east and set in the west. By the way, it's the rotation of the Earth that causes the rising and setting of the stars and the planets. What real motion is it that causes prograde and retrograde motion then? Wouldn't it be the revolution of the Earth around the sun? Well, of course. So that's the end of our blurb. So that's prograde and retrograde motion, and because we observed these objects that appeared to wander through our sky every month, and sometimes even faster, we being Greek people, they named these objects, like Mars. They ended up naming them, but the thing that we called all of these things that we noticed, there were several of these things that would wander through our sky in different days and times. We called them planetos. Planetos, and that happens to mean wanderer. Wanderer. And so these wanderers started to really interest people that would watch the night sky. We really wanted to figure out what these wanderers were. Were they gods? Were they tricks playing on us by the gods? What was going on with these wandering stars that we called planetos? Well, later on, of course, we now call them planets, but it comes from that Greek word planetos, which means wanderer. So that is an important discussion on retrograde motion, which we'll start to discuss in our next cosmology.